One way to quickly judge the acceptability of a design is to view the factor of safety results. Autodesk Simulation Mechanical allows you to display a factor of safety contour plot for linear and nonlinear stress analyses. The safety factor is computed as a function of the material yield strength, ultimate strength, or user-specified allowable stress magnitudes. These properties are predefined for many of the library materials. Each part within an assembly is listed here, and each has a separate allowable stress value. You can base safety factor results on the von Mises, Tresca, or principal stress results, or on any of the 6 stress tensor results. The stress tensors can be based on global or local coordinate systems. This example is a hopper with dual outlet nozzles. A hydrostatic pressure load represents the effects of the hopper being filled with sand up to the top flange. We are currently looking at the von Mises equivalent stresses. Let's see the safety factor plot based on this result and the material yield strength. Notice how the usual color progression in the legend has been reversed. The minimum result is red and the maximum blue. This is the opposite of stress and displacement results, where the maximum value is red. For safety factors, it is the minimum values that are important. Suppose your design standard is to not exceed 1/3 of the material yield strength. If so, then at least one portion of this model fails the criterion. The minimum safety factor is approximately 2.02, which is less than the required safety factor of 3. Because the maximum safety factor in the hopper is over 3000, the legend does not provide sufficient resolution in the areas of interest. We can adjust the legend range to remedy that. We'll turn off the automatic range and reduce the maximum legend value to 20 so that all safety factors equal to or greater than 20 will be blue. To further isolate the areas where the design allowable stress has been exceeded, we can use the threshold settings. Specify a less than value of 3 to only shade the element faces containing safety factors of less than 3. Notice that the areas of concern are along the edges of 6 of the mounting holes in the top flange. This could likely be corrected by slightly increasing the flange thickness or using a stronger flange material. On the other hand, you may make an engineering judgment that these are local stress exaggerations caused by the fixed constraints applied to the edges of the flange holes. Rerunning the analysis with the entire flange surface supported rather than just the edges of the holes produces this factor of safety plot. The flange is no longer a low safety factor component. The minimum safety factor is now approximately 3.45, and it occurs at the edge where the 2 outlet transition regions meet. Our design now passes the engineering criteria.